Hi, we've got the answers to lesson 2. First question, should you ever use the word upthrust? Simple answer, no. Upthrust is just a terrible, terrible concept. It's something that wormed its way into primary school education in this country about 10 years ago, and like a horrible parasite has remained there ever since. It assumes so many things. Firstly, that we can define up, and any of you who've thought about reference frames in any way, shape or form will know that's just a nonsense concept. Secondly, what makes upthrust different to just thrust? Like if a rocket's going up, is that upthrust and it starts to turn? At what point does it just become thrust? It's just a bad idea. The only time you'd ever really consider something specifically an upthrust, I think, might be a boat and the force from the displaced water, but just use buoyancy. It's just a better word. So if you never use the word upthrust again, you'll be a better physicist. Question 2, is there any difference between standing on the inside of a centrifuge and gravity? Simple answer, no. There isn't. You know in those sci-fi things where they're always spinning the spaceship to create artificial gravity? It's exactly that. If you think about it really carefully, and it's a little bit more complicated, so we'll go into this later, so this is more for the A2 students out there. If you're standing on a centrifuge and you're just being spun round and round and round, you're going to be pushed outwards. Well, you couldn't tell if that was the same as gravity pulling you inwards. So overall, you couldn't tell the difference, which is a fun thought experiment. Imagine you're waking up in a room, you feel gravity. Do you know if you're on a planet or you're in a centrifuge? You won't. You can't know. It's all relative. Finally, distance squared. Pretty much every force, except the strong force, but as we've already talked about, I have issues with the strong force, seems to fall off with distance squared. Gravity does, electrostatic forces all do. And when you think about force-carrying particles, you can imagine them moving out on the surface of a sphere, which would mean they would fall off with distance squares, exactly the same way that light does. It doesn't hold for every force, and to be honest, I don't know enough about the underlying quantum mechanics to know if this is a good analogy, but it was just interesting to me there that there was a parallel, and maybe there's a story that we can tell there. Something to think about.